So this here is probability, and I'm going to be teaching you about probability. What is probability? Probability is the chance that something will or will not happen, and it ranges from 0, impossible, and 1, certain. As you can see here, this is 0, impossible. 1 here is certain. This is likely. Here's the example. So, impossible, here's an example, getting a purple ball out of a machine filled with orange ball. You can't get a purple ball because it only has orange. And this one is picking a blue marble out of a bag filled with 3 purple marbles and 1 blue marble. You have a higher chance to get these purple marbles than you do to have to get the blue one. This is equal, and it's like when you flip a coin, it has an equal chance to land on heads or tails, and it's a 50-50 chance. This is likely to happen. So if this time you want to pick the purple marble and it's filled with 3 purple marbles and 1 blue marble, you have a higher chance to get this purple marble. 1 certain, it's if you try to get an orange ball filled out of a machine that is filled with only orange balls, you will get it every single time. Simple probability, the number of outcomes for a single event. So the probability of an event equals the number of favorable outcomes over the total number of outcomes. Let's try it. Find the probability so this means probability right here, and the P means probability, blue or red. So we have blue and red here. So we would put 2, and now that's the number of favorable outcomes. And now we count all of the outcomes. 1, 2, 3, 4. So we have 4. So we would put 2 over 4. And since we can simplify it, it would cut down to 1/2. So our answer here is 1/2. Now we have not green. So now we have to count how many are not green. We have 1, 2, 3. So we would put 3. And how many total do we have? We already counted, and we have 4. So we have 4 outcomes, and 3 of them are favorable. So our answer is 3 over 4, or 3/4, because you cannot simplify it anymore. Now the chance to get a yellow, we have 1 and 4. So our answer is 1/4. Now orange, we would count to see how many oranges there are, and there's 0, and we would put it over 4 because there's 4 outcomes, and that simplifies to 0. So the answer to this one is 0 because you cannot get an orange. It is impossible. Now we go down to compound probability, the probability of multiple events happening. Okay, this is kind of what it looks like. This is a table. Let's try it. So, what's the chance to get heads and 6? So first, you have to count the number of outcomes. So we will do the same thing. How many are favorable? So we want to split it in 2. So heads, how many are heads? There's only 1 heads. And how many are there? So in this case, this splits off to only 2, so there's 2. So we would take 1/2, but we're not done yet because we have to try to get a 6. So now we don't need this because we're not picking tails. So now we count how many are 6, and of course there's only 1. So we would put 1 up here. And now we have to count how many total outcomes there are. 1, 2, 3, 4, 5, 6. We have 6 outcomes, so it would be 1/6. So now to get the chance that we will get this exact thing, we have to multiply 1/2 by 1/6, and we would get 1/12, and theoretically 1 out of 12 times we will get heads and 6. Now we do the same thing, tails and odd. So now we go to tails. It's a 1 out of 2 chance to get tails. Now we want to get odd. How many are odd here? 1, 2, 3. So we would put 3 on top, and now there's 6 outcomes. So we would put 3 over 6, which is equal to 1/2. So we multiply 1/2 by 1/2, and the answer is 1/4. So 1 out of every 4 times we should get tails and an odd number. Now here's the next one, heads and less than 6. We already know this is half of a chance. So how many are less than 6? 1, 2, 3, 4, 5. So we have 5 favorable outcomes, and there's 6 total outcomes. So we would multiply 5 over 6 by 1/2, which will give us 5 over 12. And 5 out of 12 times we should get heads and a number less than 5. Now this is complement property, the chance of something not happening. So it would be kind of the opposite. Let's try it. This is complement property. So not picking purple, we're looking at this thing. So first we would count how many are not purple. 1, 2, 3, 4, 5, 6, 7. So we have 7. So we would put 7 on top. Now we count the total number. So 7, 8, 9, 10, 11, 12, 13. 7 over 13. So 7 out of 13 times we will not pick purple. Now we do green. Not picking green. So now we have to count the total number of things that are not green, which is 13. And now we count the number of total outcomes. So this 13, which simplifies to 1. So now we have the answer, which is 1, which means this is certain because this is at the top of our scale. You will always pick something other than green. So now not picking red or purple, and the only one that's not red or purple is blue. So we counted 3 over 13. So our answer here is 3 over 13, and 3 out of 13 times we will not pick red or purple. Here's some other vocabulary words. Sample space, a list of all possible outcomes. So if we're rolling a die, the sample space would be 1, 2, 3, 4, 5, and 6. That's sample space. Tree diagram, and it shows all the possible outcomes, which is the same thing as this thing we saw earlier. Simple event, an event where all outcomes are equally possible. So as we can see here, each one has 1, which means there's no more than 1 for each one. See, this one has 5, 6 purples, but only 3 blues. So the chance to get purple and blue are not equal. So this would not be a simple event. This would be. Now we will do compound event, the probability of multiple events happening. So basically this is also showing probability because this is one event and this is the second event. First we have to flip a coin. get heads or tails, and then we have to roll a dice and see what we get. So there's two events happening here. This can split off into even more, and it will get tinier and tinier and tinier and tinier until it stops. Now we have theoretical property. The probability of an event occurring, and it's expressed as a ratio. So if we take a coin, theoretically it will happen 1 out of 2 times. So it would be 1 out of 2, and this is the theoretical property of flipping a coin and getting heads, or we could do the opposite and getting tails. Now, experimental probability is the probability of an event occurring based on an experiment. So you have to do an experiment first to figure out what the probability is. So let's say we want to figure out how many times we will get a banana if we put our hand in a bowl and there was 4 bananas, 3 watermelons, and 2 oranges. How many times? And let's say we put our hand in 20 times, and basically we want to figure out how many times we would get each item. So let's say we got this one 14 times, this one 3 times, and this one 3 times also. It may not match up and it might not look right, but the thing is, this is experimental and it can change depending on who's doing the experiment and how many times you reach in. So this totals to 20, and basically the chance to get this is you get it 14 times out of 20, which is the chance to get a banana based on experimental probability. So that's it. This is a lesson on probability.